So, hi everybody, and my name is Ahmed Mufty. I'm a geotechnical engineer holding a PhD in geotechnical engineering. I'm welcoming my friend here, Mr. Santino Tersigni. Santino graduated from the University of Toronto with a Bachelor of Science. He worked in many capacities through his career. He's old enough now. He's in my age almost, or maybe 1 year more. In June 2011, Santino began his career with Maccaferri until he became the central area manager of the central region here in Canada. During his 20 years plus with Maccaferri, he has developed a thorough knowledge of retaining walls, construction, and having involved in a range of projects, from small home projects to large developments. He's the main connection between consultants and Maccaferri's technical department, providing on-site assistance, also providing demonstrations on the assemblage and installation of the retaining walls. Welcome again, Santino. I'm glad that you accepted my invitation.
Ahmed, it's my pleasure. Thank you so much for having me on your podcast. I'm honored to be on your podcast, one of the first ones, which is great.
That's Thank perfect. You. I was always interested in Gabion walls, and fortunately, I worked with you in some way. So I'm interested to listen deeply to what you can present about Gabion walls. You're sharing something. I'll enlarge the
that's perfect.
Screen. Yeah.
No, Ahmed, thank you so much. No, I'm glad that there's this interest in these Gabion walls. I mean, these Gabion walls. During this presentation, if you have any questions, Ahmed, as we go along, by all means, we can discuss it.
I will interrupt you many
Perfect.
times. Don't worry.
I guess that's the professor in you, interrupting as people talk. So I'll start it off, Ahmed. The Maccaferri Canada is part of the Maccaferri International Group, and its beginning started back in the 1950s. A gentleman by the name of Joe D'Addario. He was a geometro, and a geometro was a draftsman back in Italy. He came up with the idea or the concept of bringing gabions into Canada. They were originally used internationally, but they weren't really used here in North America, the use of these wire mesh baskets. So Mr. D'Addario started bringing them in. And fortuitously, or not fortuitously, back in the 1950s, there was something called Hurricane Hazel. It was a huge hurricane that took place in Toronto. Major devastation, major problems, hence the reason why a lot of these conservation authorities started or developed back here in the 1950s. Well, what the wonderful part about it is gabions were used in Europe for a lot of transportation works within the watercourses. So Joe D'Addario had the perfect idea. Why not use these gabions for watercourses? And that's why you see a lot of old watercourses are used in conjunction with gabions. And they're used for actually bank stabilization along the banks. So when you start looking at them, you start seeing gabions used all over the world. As I mentioned before, we started back in the 1800s when the Maccaferris first got their patent, but they've been used extensively. The gabions themselves, they're used in many configurations. They're wire mesh. The wire mesh is either used for anything from the gabions to you're looking for rockfall mitigation. Testing's been done on the gabions to make sure that they're properly manufactured. They're used for erosion control in something called gabion mats or Reno mattresses. Again, back in the early days, they were cylindrical in shape. A Gabione or...
Do you know the time these photos has been taken?
Well, that looks like a big steam shuffle. I wouldn't be surprised if these photos were taken back in the 1940s or 1950s.
Do you know when the Gabion walls been used first?
Well, the Gabion walls, I'll get a bit back into the history, but Maccaferri introduced it back in the 1890s. Maccaferri introduced the Gabions, but the Gabions have a much older history, and I'll get into that in a minute.
We're talking about 130 years for Maccaferri.
Yeah. Over 100, that's correct, over 140 years. And actually, Gabion is used in a different ways. Gabion in Italian is Gabione, and in French is Gabion.
Gabion, yeah.
Gabione, which actually means cage. Gabion is a cage, like a bird cage.
Oh, I thought it's a person's name.
Yeah. No, actually, Maccaferri is the person's name. And the Maccaferri, they were blacksmiths. Macca means to beat, and ferry is Ferris. So you have Maccaferri, which means blacksmith. Is how the name Maccaferri came about. But now you see these cylindrical gabions, and the same thing, they were used for erosion control. Rocks filled with baskets, or baskets filled with rocks, and they used for shoreline protection. These same gabion mats are also used for erosion control underneath bridges and structures. So again, it's diversified in terms of what you can actually do with these gabion structures. And yes, they've been used for a very long time internationally. But the main thing is, you asked about the history. What's interesting with the Gabions actually started back in the Egyptian times. The Egyptians used to get reed baskets. So the reed baskets were filled up with rocks, and they were used along the Nile River to stop erosion along the Nile. And the same concept of baskets filled with rocks were also used during the medieval time for fortification. So there was a battle, there was some kind of a disturbance. They would get, again, wicker baskets, fill them up with rock. Once you have this, you can actually fortify your castle. And during war times, and Maccaferri was around during the World War, both the first and second, same things would happen to more or less fortified bunkers. They were used for fortification, the Gabions themselves. Again, you're filling these things up with rocks. You're creating mass is what you're creating with these things.
Yeah.
So where did the Maccaferris come in? We talked about reed baskets. We talked about wicker baskets. What the Maccaferris did, they modernized it. They introduced steel. They introduced the weaving system. So they had a small problem along the Reno River in Bologna, Italy. The same problem that happens nowadays, you have erosion along shoreline. Yeah. The Maccaferri solution, take these wire mesh baskets, the same thing the Egyptians did, is take these wire mesh baskets, pile them up along the riverbank, and let's see what happens. What's interesting is we go back over 100 years, and if you look here on the right-hand side, if you go to the same location in Bologna, Italy, along the Reno River, you still see the gabions there. So the biggest question we get asked all the time is, how long do your gabion structures last? Well, we have structures that Maccaferri has been working with or has actually installed that are over 100 years old, which I think is pretty impressive for a company.
Yeah. These ones which are already 100 years, are you talking also about steel meshes?
Yes, it's steel mesh. The mesh itself, there's approximately a 30% depreciation in the mesh. Some other areas, obviously, you're talking about a structure that has gone through many floods and many disturbances, but the essence of the wall and the essence of this erosion control measure is still in place.
Okay.
Yeah, which is quite impressive. Now, Maccaferri, from its humble beginnings in Bologna, Italy, is now an international company. We're right over the world, anywhere from Australia all the way to South America, into Russia, and right across North America. So it's an international company. What does it mean for everybody? Which means there's a level of standardization. As you know now, or globally, everything's our backyard. We can be in North America and we're designing things in Australia, or we can be in South America and we're designing things in Russia. Anything is possible.
That's globalization.
Exactly. So that's where people can take the advantage of this globalization by using this type of practice. So Maccaferri has diversified quite a bit. Again, from this basic Gabion concept, we've gone anything into rockfall mitigation. We go into dewatering, environmental. We get into other types of geosynthetics. We get into erosion control systems. So the company itself, because of the Gabions and the demand by the outside consultants, demand by our clients, the company's actually expanded in a lot of ways. We also get into ground stabilization, ground reinforcement, erosion control measures, erosion blankets. There's a lot that's done. Soil nailing, soil anchoring. Again, the company itself, it's diversified. The main crux today, though, we're going to concentrate on gabions. That's really what we're going to be doing. So the main area we're going to be dealing with is retaining walls, and in particular, gabion retaining walls.
I wanted to tell me, why should I go to Gabion walls?
It's a 130-year-old technology, and it's been...
Yeah, why should we choose Gabion walls?
The biggest advantage to the Gabion walls, Ahmed, is its simplicity. They're a basic gravity wall or semi-gravity wall.
So we can say, for example, I will save a lot of time for the project.
There's a time aspect, but there's also a security aspect. The best part about Gabion walls, let's say versus a concrete wall, we don't need a foundation. Gabions can more or less be placed on grade. Slightly bared, but we don't need a foundation for a Gabion. So they're excellent in North America where we have freeze thaw.
Yeah.
They're great in places where we have the tectonic processes, where there's, let's say, a lot of earthquakes. The beauty of the Gabions, and I'll show you in a bit, everything is connected together.
They're also more flexible than a concrete wall.
Exactly. And that's the benefit of the Gabions. You see them used in Europe almost exclusively in the mountainside for that flexibility. Everything is clipped and laced together to create these monolithic structures rather than blocks being placed together. That's where these benefits come into.
I use the Gardner Expressway every day, and I see Gabion walls on my way. Are they yours?
Possibly. If they were done a while back, they are. But
no, it's like maybe recently, maybe 1 or 2 years, and they're still working nearby.
Possibly. What's happened though nowadays, we have to be careful, and we'll talk about it also, is there's an influx of Gabions, and you'll see this internationally, and this goes for all your engineers and your consultants out there. There are products that are coming to job sites that sometimes they say they meet the specifications, but sometimes they don't meet the specifications.
Then you need to talk to me and tell me about the quality control measures to be sure that these are meeting the specifications.
Absolutely.
We'll pass through them anyway. Let's see what you have here.
Not a problem. We can definitely get into that. In terms of the wire itself, as you mentioned before, Ahmed, the original Gabions were non-coated. They're just a black steel, I would call it. We went from a black steel to galvanization. From galvanization, we went to PVC coated. From PVC coated, we now get into polymac coating, which is a new type of coating. It's a polymer coating that's much more chemical resistant than even the PVC material. And I'll talk about polymac.
So your new wires are already made of 3 materials?
Correct.
Three levels, okay.
Correct. We have the steel, the zinc coating, and the polymac coating. So there's the 3 levels of security of more or less resistance in terms of corrosion effect. And the best part about the Gabions, you mentioned why these Gabions should be used. Again, from an engineering principles, it's no problem. But in terms of environmental, and now we always talk about greenhouse gases and other things, the best part about the steel, we can use recycled steel within our mesh. And this one, the actual Gabions themselves, the steel has a percentage of recycled metal within it. The polymac coating, and that's the benefit of the polymac coating. We're finding out that the old, sometimes the old steel is not the best steel. Sometimes the new steel has to be vamped up a bit, and that's where the polymac comes into. With this new coating, we're able to get better abrasion resistance. What is abrasion resistance? If you think of it in water course applications, as much as the water seems clear, for streams, creeks, rivers, there's always particles within the water. And this particle has a sandblasting, this abrasion effect. And that's where the polymac comes into play. It's 10 times greater than regular galvanization and regular PVC coating. Much better. low temperature resistance, UV resistance. You find now that the UV obviously is much higher, and this is not only in Canada, this is also international, and that's where the Polymac excels.
Well,
As well as
for us, low temperature is important for us.
well, especially
We're
now we're
freezing
doing
all
this.
the time. Yeah. We're freezing all the time. Yeah.
Yeah, so it's like it's one of the disadvantages of being in the Canadian. I wouldn't say the Canadian Arctic, but in the Canadian environment, we have these 4 seasons, and this cold winter season. Yeah, definitely, it's very cold. So again, this also goes into resistance to installation damages and chemical resistance. So overall, we've done the testing with it, and Polymac is the material of choice when it comes to areas where there's aggressive environments, and that's where we like to use it.
Listen.
The wire itself, we use what's called an 8x10. It's an 80 by 100 millimeter opening size. So when we actually see this from side to side, it's 80 millimeter nominally, and from top to bottom, it's 100 millimeters. And that diamond. What does that mean? If we're using rocks within these gabions, you want to make sure that these rocks are larger than the opening size.
Of course, yeah.
I say this, Ahmed, but and over the last 20 years, I found I've been to situations where they actually use smaller rocks in some of these job sites, and it amazes me. This is why I keep saying it's basic.
Yeah, it's not a must that they will flow out.
That's what I'd say too. But
Yeah.
again, what happens though is in a quarry, and we'll talk a bit more about rocks.
Most probably the friction between the rocks will keep them in this basket without any movement. What is this 2.7 millimeter? This is the wire size?
That is correct. What we have is the actual wire itself is a 2.7 millimeter wire for the Polymac coating. So the wire is 2.7 millimeters, and there's a 1 millimeter coating around the Polymac, around the wire. So the complete thickness is 3.7 millimeter for the wire that's coated. We all have a zinc coating, and the zinc coating uses a 3 millimeter wire. And that is only zinc itself. So those are the two basic sizes, 2.7 millimeter with the 1 millimeter of Polymac, and the other one is a 3 millimeter zinc coating. So why have these gabions been around for so long, Ahmed? If you look here, and this is where the Maccaferris received their patent, if you look here, you'll see something called a double twist. The double twist is different than
okay.
It's twisted twice.
Yeah, I'm thinking it's twice, really. Yeah.
Exactly. Well, what's single twist? Single twist would be your fence in your backyard. That would be single twist.
Oh, so there is single twist.
Single twist would be your fence. So yeah. Typical fence between neighbors, a simple fence you see, let's say, on a traffic, in the transportation courses, that's single twist. What's so great about the double twist? It doesn't unravel. In other words, if there's any type of mechanical breakage, you're not going to be able to pull the wire through. It actually stays in place. So theoretically, in order to place a hole in a gabion, you literally have to create a couple of breaks in the linkages, push the wire down so the rocks can come out. This is why you see a lot of the double twist wire being used in rockfall mitigation. If you ever traveled along mountainside, you might see a lot of this rock mesh. For that reason, you don't get this unraveling effect. And that's where the biggest benefit of these double twist wire is.
Okay.
So the process itself is straightforward. What we have what's called weaving machines. The same way you weave clothes, you're actually weaving wire mesh is what you're doing. And you're creating it. If people go online and then if your audiences goes online, you can actually see the weaving process. It's actually kind of neat. It's a very interesting process. And it creates this mesh. And the mesh that's created, once it's done, this mesh is then made into baskets, into gabions, or it can be made into other products that Maccaferri manufactures.
Do you produce the baskets in the same factory, or you take the wire mesh to another factory for that one?
It's all in one factory. The same place that we get the raw wire, The wire is given to us. The wire, once we have it, in certain places, we actually draw the wire ourselves. We also coat the wire with polymac in-house in our facilities. Once that's done, the mesh is drawn out either in 2-meter sheets, 3-meter sheets. We can also go up to 4 meters, but 2 to 3 are the standard.
So
and
these
then
are not rolled in long rollers.
they can be they also can be rolled if used for rockfall mitigation. We also sell rolls of mesh.
Oh, so you can do either.
That is correct. Though
sheets or rolls, yeah.
So once we have the rolls can now be changed. We can now cut the rolls. We can now modify the rolls. So we can actually create baskets, as you see there on the left-hand side. So we're carrying out baskets. In North America, these are our standard sizes in North America. 4 meter, 3 meter, 2 meters, 4, 3, 2, and they're either 1 meter, 1 meter wide, and a half a meter, 1 meter, or 0.3 meters in height, the baskets themselves.
Now, which one is the height?
It's 4 meters. 1 meter is the depth.
4 meters is the length. 1 meter is
the depth.
The width.
Is the depth, the width. You can say width, yes. And 1 meter is the height.
Is the height. So the one changing is the height. So
correct.
You have 1 meter, 0.5 meter, and very short one.
A 0.3.
0.3 meters, 1 foot. Yeah.
Correct. Though I'll show you in a second, if you look at the baskets become flat. So theoretically, you can get a basket, and during the assembly of it, you can shift it on its side, so it can still be 4 meters. Now it can be either 0.3 or 0.5 meters in width and 1 meter high, by how you actually lace the basket together.
Okay.
Right? So when they do come to the site...
How do you fix these baskets? You do them at site, right?
Correct. And that's the benefit to the system. They come in bundles. Once they get to the site, think of it as a banker box you would get at one of these stores. The box, you fold it together. Once the box is folded, it's either clipped or laced together at the edges. And you create individual boxes.
What do you use for the clipping?
The clipping is something called a Spenex clip, and I'll show you that in a minute.
Yes, please.
These are pneumatic rings. It's like a C, and the tool squeezes it to make a complete circle, to make a clip, completed clip. So if we start with the regular gabions in the bundles, they're assembled into your baskets, and then they're placed into the wall configuration, as you see here on the right-hand side. So why have these baskets been around, and why have these walls been around for so long? If we were to analyze this wall over here, and you were to take it apart, you'll find that that middle basket is clipped to the basket to the right. It's clipped to the basket to the left. It's clipped to the basket on top, to the bottom, and if it's in the middle, it's even clipped to the basket to the front and to the back. So what this is one giant monolithic structure. So as we discussed before, because you created this monolithic structure, it's great in areas where there's differential settlement. It's great in areas where there's seismic activity.
It will give you a lot of flexibility for the movement.
That is correct. That is correct. And that's the benefit to the system, is that flexibility. And you mentioned about how they come to the site, and this is another benefit to this type of system. Because we can carry so many gabions to the site, there's a huge reduction.
The only two materials you need is your gabion meshes and the rocks.
And the rock, typically you have a rock.
Maybe a couple of boxes of clips and that tool you're talking about.
That's it. So they can be shipped internationally. So when Mr. Joe D'Addario was here in Canada, he was shipping them, and you were getting lots of material in a container versus concrete blocks. Nowadays, these blocks are anywhere from a ton, 2 tons sometimes. So there's a lot of carbon wastage using a lot of these blocks. I understand the efficiency aspect of it, but again, this is something to consider during the process.
Well, of course, it's considered these days. But I love it. That's why I love engineering, because always you can have different solutions, very simple solutions for very big problems.
Exactly. So Ahmed, you mentioned about the clip. There it is right there. It's something called a Spenix clip, and it uses something called hog rings. It's a pneumatic tool. You need a compressor to operate it. Once you push the trigger, it creates the clips. And typically this is what we use in North America. We also have wire, and this wire can also be used to do it manually. So the manual system is just lacing it together. Same way you would lace, let's say, your shoes, you would also lace these gabions together.
So are these having special tests?
Correct. We've done testing on both the lacing as well as the Spenix clips, and it's comparable. Either system is acceptable. In Ontario,
do you know what kind of tests you applied? Is it just a tension test, or what do you use usually?
It all goes by ASTM A978 is what it is, 8 ASTM standards.
We will check that, no problem. Yeah, okay.
But that's through ASTM is when we do the testing of it. So the next is the rock. We discussed the rock. The rock right now that's typically used, you're looking at a 100 to 200 millimeter stone is what you'd like to use. And it's a gradation of stone. Typically, it's a fractured stone that is used. River run stone is sometimes used. We don't recommend it because of the roundness, and sometimes it doesn't have that interlocking.
We will lose the friction. I don't agree with river stones. No, river.
But they're done. Sometimes it's available, and if done properly, I mean, the walls could still be done. But again, I'm a fan of like
you will have less stability for that. Yeah.
I'm a fan of the angular rock, is what I am.
Of course. And it's cheaper, I think. No? Which one is cheaper?
What's cheaper right now is usually what's closest to you. So if there's a quarry nearby, typically it's a quarried stone is the cheapest here in Ontario, where we are. And there's quarries right across Ontario. So typically the nearest quarry is the best. The river run stone usually is a premium for river run stone. So the other thing that we get into too is, can we use recycled concrete in a gabion? That was one of the questions that get asked. We actually had a couple of projects. The answer is yes, you can use recycled concrete, but there's a caveat. As long as it's air-entrained concrete, so if it came from a sidewalk, if it came from a curb, as long as we know it's not going to break down with freeze-thaw, you can actually use recycled concrete within a gabion, which is a huge for carbon. If you think about carbon footprint, if you're doing urban work downtown, let's say in Toronto or downtown Cambridge or anywhere else, this is great. You're reusing material to create a wall, which is fantastic.
What do you mean by which concrete you said you can use?
It has to be air-entrained concrete, meaning that there's air entrainment so that it deflects from the freeze-thaw. So the concern is freeze-thaw, and it'll break down the concrete. If it is an air-entrained concrete, it might break down. So if it was an old concrete curb, if it was an old concrete sidewalk that is air-entrained, that was designed and developed for use in applications outdoor, if that is broken down into a 4-inch to 8-inch or 100 to 200 millimeter stone, that's perfect.
Okay.
So as a manufacturer, one of the biggest difficulties we have, Ahmed, is installation. We provide design assistance, we distribute, we also have resellers across Canada, but we can only do so much. I go to the site, I can train the contractors, but there's a level of skill required to the installation of these walls. And here on the left-hand side is one where we tried our best to work with the contractor, but they just didn't have the skill level. If a true gabion wall is created, like the only merit I give to this wall, you see this bulging? This bulging is consistent, though the gabion wall should not be bulging. If done properly, the wall should have a very flat appearance. It should have a cladding-like appearance in the front. And that's done by actually hand placing the stones in the front. And that's how you get that beauty. That's how you get that interlocking effect and that stability. How does that work? Well, it'll be up to the consultant. It'll be up to the site engineer to make sure that the due diligence is done by the contractor to make sure that he does a proper job during the installation. Like anything else, if the asphalt isn't put in properly, take it out. If the concrete isn't put in properly, take it out. If the Gabion wall isn't done right, take it out until it's done properly.
Did you ever try to use like these paver coatings that we use for our backyards, and you know this it gives some glossy look to the like wet look to the rocks.
So this will be like a coating on it, or this will be like a shellac on it, you're saying? Or
I don't know what
glossy?
what do we call that. It's like you spray it with a material that keeps it look wet, something like that. I think it will be very beautiful to use that.
We've seen projects around the world. If you really want to get into it, what you can do by using different colored stone, you can actually create designs and patterns in the Gabion.
Yeah, I think it's worth it to study this issue, because if we have something beautiful in addition to what other benefits are, that will be great, I think.
I agree, Ahmed. It seems like, unfortunately, in this North American mentality of ours, it's quicker, faster, better. The artistic value seems to be disappearing. The flair for being done properly and being done with care and being done for, let's say, for longevity, we seem not to push that aspect, which I think, yes, it should be pushed a lot more. I'm in agreement.
But we call it sealing.
To seal it, yes.
Yeah, we call it sealing for sealing the pavers.
Yes, paving. Yes, it can be done. If you like, it can be.
We can use this on the Gabion walls, no?
To give it that shiny look, that glossy look.
It may have a very nice look after sealing. Yeah.
I think you're onto something, Ahmed. You should patent that idea.
We need to have a patent for this one. Yeah.
So, design of Gabion walls.
This is what I like. Yeah.
This is you, and you can, if you like, then you can talk about it. Typically, with the design aspect, there's a couple of ways of doing this. Option A is we have design manuals where you can do it manually. We can provide that for the consultant to design these Gabion walls. That's option one. Option two is, as a manufacturer, we provide design assistance. So as you give us the various information, foundation soils, the angle, friction angle, unit weight, loads, things of that nature, we can actually do the design for you. These are preliminary designs, but we can provide that for you. The third option.
The geotechnical part here the geotechnical engineer should care for a couple of things here. First, we don't use Gabion walls as embedded retaining walls. So they're not embedded. They are built, and the space behind them is empty. So you need to fill the space while you're building them. The second thing is, most probably, the material behind the wall will be draining. You can't keep that material let's say saturated. You can't keep it saturated. It's always draining. The other thing you need to know also is that the stability of the Gabion wall depends on how wide it is at the bottom. So you start wide and you go narrower while you're building it upward. The type of forces that are applied here, so because it's drained behind, so we don't have really water pressure, and that's a very good part compared to retaining concrete walls, because it may retain the water. So there's a water pressure behind the concrete walls, where in Gabion walls we don't have this problem. So the other thing is it's easy to design it against earthquakes. You just need a pseudo-static method for design, and you can also check the full stability of the slope with the Gabion wall with a slope stability program, or you can use maybe a spreadsheet or something. It's simple in design and very, let's say, the results are almost rigorous because the controlling parameters and the variation of these parameters are much less than what we will have or face in a usual gravity concrete retaining wall.
Exactly. And this is why with our design software, GeoGuides, it does all that. It looks after the internal stability, it looks at sliding, it looks at overturning, it looks at other active pressures. Again, there's different scenarios that it actually deals with in the software itself. And this is a free software. If anybody would like the software, they can contact us. And it's a download, and you can use this actual software to design your Gabion wall. And that takes all those factors into consideration.
And then for the whole stability, we can use also our program that is slide 2 or slide 3.
You could use that too.
We don't want the whole advertisement here for Maccaferri. Let's go a little bit with Rocscience also.
You can definitely do it also. Yeah. We're okay. As long as you use our Gabions, I don't mind. And going back to your point, Ahmed, there it is right there. Those are your two basic types. Either you have a gravity wall you see there on the left-hand side, or we have a semi-gravity wall, as you see there. Either one is totally acceptable. When would you use one over the other? A lot of times it has to deal with who's flipping the bill. If you're the homeowner that has your house at the top, chances are you'd like this type of system because you're gaining a bit more land. If you're the homeowner at the bottom, chances are you'd like this type of system because you'd like to look at a stepped structure rather than a, let's say, a very high structure.
There are many factors to choose which one. Also the material behind, who is providing it, how it is constructed. I think which one do you think will be more costly?
Either one is acceptable, Ahmed. It doesn't make a difference for us. Typically, in most instances...
And it's beautiful how you showed this because there's a little bit angle, a small angle at the bottom that keeps the stability of the wall higher, because if you put the wall exactly horizontal at the bottom, that will have less stability than this case. This will offer more stability, especially if you have earthquake effects.
Well, our biggest concern as a manufacturer, and even for the client, is what happens as we go back to the first discussion we had. These are flexible systems. If these units are perfectly vertical, if there's any slight movement, chances are this Gabion wall will still be in place, but will always have this look like it's going to fall down. It always have this over-toppling look on it. So this hence the reason why we provide a bit of factor of safety and have that batter placed.
Yeah, that batter out of plumb is a very good idea, because it will give also some beauty also to the wall. If you have like a straight vertical wall, you will have some. You will not be very comfortable, right? You will feel some. Yeah, when you see it slanted a little bit to the back, you will feel more comfortable. That will never fall on you. Yeah.
Yes, exactly. And you brought up some other good points too. In terms of the baskets themselves, again, we're dealing with the typical Gabions are 70% rock, 30% void space. So within a Gabion structure, within that area, there's 70% rock, 30% void space. Literally, you have riprap, so you have a free draining system. So this is great for any hydrostatic pressures. If there's any artesian well, if there's water buildup behind it, the beauty of the system is it can freely drain out. That's the biggest, one huge advantage for these Gabions, especially here in North America, where we have a lot of freeze thaw taking place in the spring thaw. Again, if everything gets built up, again, that hydrostatic pressure is more than likely going to topple over that concrete wall. if it's not
It's not
drained properly.
it's not very clear for me because the view is very small, but I think there is some drain at the bottom you're showing.
Yes, even though it is free draining, what we end up doing is we
Right.
have a drainage tile at the bottom. The concern is if there's any water buildup or any pressure buildup below the wall, the drainage tile is daylighted. So we like to have that drainage tile where it's actually exposed and it can remove any water that's submerged or below ground
And
level.
it's also better to collect this water to some sump or something, because if you don't do this, the water will build up, will rise inside the Gabion wall. Then it will start flowing outside, and my walkway or my area in front of the wall will be always wet, right? So
Exactly.
this will help to collect that draining water into some regions to collect it and pump it away.
Exactly. And that beautiful sealer that you put in front of the wall is going to look ugly now because all this water is going to come through and destroy that sealer that you have in the front.
Exactly. You will have a dry look anyway. Yeah.
So from here, Ahmed, I'm just going to simplify it a bit for you.
This is
A,
beautiful.
ga- a Gabion, a Gavione, a Gavion. It's again, they're wire mesh baskets. Wire mesh baskets, if you use engineering principles, we can create retaining walls. If you just want to use them for architectural detail, you can use it for architectural detail. Or if you're more into hydraulics, these gabions could also be used for drop structures to dissipate energies and dissipate water flows. So again, they're used in different applications, but again, different principles are used. Again, they're wire mesh baskets. That's all they are. Very simple.
Let me ask you this question. Uh, how high I can go with a gabion wall?
For gabion walls, the highest gabion
I
wall,
mean, yeah,
yeah, it's a good question. The highest gabion wall I've seen to date is over 20 meters in height, the highest gabion.
20 meters.
Correct. There was a reason for it, but again, it was over 20 meters. Typically, gabion walls, it becomes a cost-effective aspect of it. Within 4 meters, 5 meters, they're cost-effective. Once you start getting over 4 meters, over 5 meters, you start looking more into mechanically stabilized earth walls, MSCW walls using tiebacks and using granular backfill. It becomes a cost issue. That's all it is. But gabion walls, in terms of height, no, like I said, up to 20 meters. I've seen walls up to 20 meters, and there was certain reasons for creating a wall that high.
Yes, sir.
So there you go. So wire mesh baskets you filled with rock.
No, there was another. Yeah, this one. This picture I like. Because
Again,
if I was there, I would. I don't know if I will swim in that swimming pool. But I'm supposed to accept it because I know these all these things have been checked. There's no stability problem, there's no failure problem, and it looks nice. In fact, with the swimming pool,
well,
it's more
again,
natural.
Ahmed, I've unfortunately what we've created in this society for everyone that says black, someone will say white. For everyone that says tall, someone will say short. For everyone that loves gabions, there's a group of individuals that rather see something else for whatever reason. For myself, these are the beauties of the gabion. The beauty of the gabion is using a natural stone. It's using in native stone. It's the hand placing. It's the artistic value behind it. That's where I see the beauty of it. Where some people might see that in other ways, but I see that certain beauty associated with gabions.
Give me a couple of minutes more and tell me about the durability. How can we ensure durability of these walls, and how long do you think the durability will be?
Well, right now, in terms of durability, Ahmed, the beauty with the gabions is with the polymac coating. We have done testing on the polymac, the in situ testing. There's a part of our international group. We had it tested in the UK out of the BBA, the British Board of Agreement. They've given it over 100 years, 120-year longevity for the polymac coated wire. So in terms of longevity, a very long time is what we have for these walls.
Do you have any limitations that, or let's say, some alert movement values or some thresholds? I don't know. What do you call them? Like any limits that when you reach, you monitor? Can we monitor these walls anyway?
The walls can be monitored. The majority of Gabion walls, and I speak just for myself, I don't speak internationally, but for myself, the majority of Gabion walls that I've dealt with, I have not seen anything catastrophic. I haven't seen a Gabion wall, all of a sudden it just came tumbling down. If there is any movement, if it wasn't put in properly, or if there was some kind of settlement or other issues associated with it, you'll see this gradual movement of the wall. It's a very gradual movement. So the indication, the signs are there that there's something happening. But we don't have this catastrophe where the whole thing, it's here one day and it's gone the next day. Typically, there's some telltale signs saying that this Gabion wall, there could be something wrong with this Gabion wall.
Let's not talk about the slope or the retained soil, how much it will move. Let's talk about the Gabion wall itself. If there's a deflection in the Gabion wall, like in the middle of its height, there's a little bulging. How much bulging I should accept, and how much bulging will be an alarm for me?
Well, that's something, Ahmed, yourself as an engineer, I'm not here to give you standards in terms of what it is. What the best bet is, if you do see some kind of movement in the wall, to have an engineer look at it, to make sure it's sound, to look at the entire wall. In terms of the bulging itself, if it does become a point where it has to be repaired, again, gabions are laced together and clipped together. That section would have to be removed and a new section placed in. If the gabion is damaged, if the wire is just damaged, that section, think of it as a bicycle tire. That section, more mesh can be placed over top of that area and simply clipped to the basket. If it's just the mesh that's damaged.
Maintenance is easier anyway. Yeah, it makes sense.
With the gabions, like I said, there's a lot of benefits to it. And the biggest benefit is, again, the repairability of the gabion.
Have you ever shotcreted an existing gabion wall?
We had one project. I don't have it during this presentation. It's during the slide deck. We have one project in Quebec where it was a park in Quebec where the gabion wall was shotcreted to give it that rock face look. So the entire gabion wall was shotcreted. Again, this brings into effect other engineering concerns, and one of it is a drainage aspect. One of it is making sure that the gabion is properly installed so that when it is shotcrete, there's no movement and everything starts to crack on you. But yes, it can be shotcrete. Absolutely. It can be done. So in terms of itself, again, different areas using different things. And this particular one, this is for transportation works in a railway. And here you can actually see the gabion wall, and you can see the cross section of the gabion. Along roadways, you see them a lot of times along roadways. In this particular instance, we don't see any vegetation growing. In some instances, we actually have areas where we get vines growing through this. We have vegetation growing through the gabion. So it actually blends in very nicely with the surrounding area.
Yep. You mean intentionally or by nature?
By nature. What ends up happening is over time, you do get depositional material. You do get, let's say there's a storm, seeds get blown around, seeds do get embedded on the rocks itself, and you do get vegetation growing on it.
How about animals?
A good question. Two things can happen with the gabions. Either A, sometimes we do have some animals that burrow into the gabion itself and create a hole. Other times, if it's south-facing, sometimes it's a deterrent because it's very hot. So a lot of animals don't like burrowing into the gabion itself. So again, it all depends on where it's located. It all depends on what's behind it. It all depends on its surrounding in terms of animals. Typically, the gabions themselves, with the mesh, with the rock, it's typically a deterrent, more of a deterrent than a place, a habitable place for animals to live, let's say. Testing, you mentioned about testing of the gabions.
Yeah, that's important.
Yeah, we've done all types of testing on the mesh to make sure that once it is tested, yeah, for our designs and for our design software, that we know what we're dealing with. And quite a few different testing is done. And testing is done on a regular basis, as well as what we do also is we have certifications for our Gabions if requested, where the wire is tested at our manufacturing facilities to make sure that it meets the requirements that are on our spec on our
You have
product.
here in the slide, you have shear and bending test. It's tested just like a beam. Then you have a compression test. What's the failure in this compression test? The wires will get cut, right?
Once it blows out, that's correct.
Yeah.
Once it blows out, as you can tell, it's quite a
And
bit of flexibility.
yeah, the first one on the top one on the right is the wire mesh tensile test. In this case, you need to test the wire itself, and you
Yes.
have a full scale test.
So there's all different types of testing that we do on these systems for the Gabions themselves. We do a complete analysis of it when we put it together. Yeah. So again, it's something that Maccaferri right now, and that's one thing with us, Ahmed, is as a company, we are the ones that provide a lot of it. And unfortunately, it's just one thing with the company itself. There's a lot of things, a lot of other, I guess, things coming in from abroad. And as a company, we provide a lot of the backup for our systems. We provide the design, we provide the more or less the education, we provide the assistance, and that's something that unfortunately I have a concern with. A lot of times, a homeowner, a contractor will look at, well, your pricing might be more expensive than somebody else. Yes, but we're here. We've been here in Canada for the last 60 years. We've been international for the 140 years. If you do buy from this other company, where's the warranty? Where's the guarantee on this? What happens to this thing? Is a person going to come out and see what's happening with it? And that's where Maccaferri comes into play.
Right,
We're there.
of course.
There's that aspect of it. So in terms of flexibility, we discussed it, and here it is right there. This gives you a level.
It's very clear that the wall is standing strange and difficult conditions.
As well as you mentioned it coming out. This one here, there was a bit of a landslide above the wall itself, and this landslide actually pushed out the gabion. Typical walls would have just came out right into the stream, whereas this one actually deflected. The gabion itself deflected. And this one here, again, I'm not too sure what design methodologies were used for this, but the gabion, the lonely gabion is at the bottom, and they stacked all this armor stone on top of the gabion. We were not notified of this when this wall was installed. I noticed this after the fact, but you can see all the armor stone holding up all the gabions holding up the armor stone here.
Yeah, you need to make some back calculations that why this one could hold this load, and that's nice. So at least you have another benefit of gabion walls. That's to hold big rock pieces.
I never thought it would do it, but yes, it's actually doing it. So I'm getting close to the very end of this slide deck, Ahmed. Overall, we found that the actual gabions themselves, there is a cost.
This is around 5 meters or 6 meters, huh?
Yes, we take that every unit is approximately a meter in height. Yeah, it's around 5 to 6 meters in height, maybe even higher. If I look here, we have 1, 2,
if each one 1 meter, 1.5 meters, you go with each one. So you're talking about 1, 2, 3, 4, 5, 7.5 meters.
Yeah, it's a pretty high wall that we're dealing with.
That's right.
But what's great with the gabions, we go back, and this is my summary page here. We still find it's a very low cost system compared to other systems when it comes to retaining walls. Whereas that flexibility, that's great with it. Again, we don't need a foundation for these gabions when we're designing with it. They're free draining, so it's fantastic from a free draining aspect if there's any types of water pressure that might be behind the wall itself, or even during freezing and thawing, especially in the North American environment. Vegetation, and maybe in some areas you don't want to see the vegetation. In some areas they like to see a bit more vegetation. In some of these stepped structures, we do get vegetation growing on the front face of these gabions. And other things we've noticed from these also, Ahmed, is we found that with the Gabions themselves, anti-graffiti, you don't get a lot of graffiti. On a lot of the block walls and a lot of the concrete walls, we tend to get graffiti on them. You see a lot more graffiti. Whereas on a Gabion, you don't see that graffiti typically. And it's because of the actual Gabion stone itself. It isn't a perfectly flat surface. Because it's not a perfectly flat surface, you're going to need a lot of spray paint in order to get your message across. Another thing that happens too is noise suppression, sound attenuation, noise barriers.
Yeah, that makes sense. It will really suppress the sound from reaching the other side. Yeah.
Exactly. We still have, again, as much as this Gabions are interlocked in the front, there's still void spaces in there, and those void spaces do act as an area to absorb that sound, as well as the Gabion stone is not perfect. And because of the angles aren't perfectly flat when you're facing it, you don't get
this will really lessen the echo and isolate the sound transmission.
Correct.
What else we have here?
And the last one here is the effervescence. We call it the efflorescence. What happens sometimes with concrete, even manufactured concrete stone, you have this this natural efflorescence that comes out of the stone itself. And using just regular or natural stone, you don't have it happening.
Because they're already weathered. They've been washed many times.
You have natural stone, exactly, that's coming out of that's being used, exactly.
Okay, sir.
That's really that part of it. The next part of it is more or less a carbon change. And if a lot of your audience is into this, we find that Gabions themselves, if you start doing an analysis of the Gabion walls or some of our Gabion structures, let's say versus concrete, versus some other systems there, you find that there's a huge benefit from a climate change benefit to a reduction in carbon footprint benefit. Because we're using, again, natural material. All we're using is Gabion stone that's been crushed, let's say from a quarry, or even river run stone, like from a local area that can be used within a Gabions, rather than using concrete that has to be put through a kiln with limestone to create the concrete mixed with cement and everything to create these walls. So huge benefits within that respects. So again, if we look at a concrete wall versus a Gabion wall, and we look at the wire mesh that's used versus the cementatious material, again, huge reduction in carbon footprint from a wall standpoint.
And the most important thing, the cost, because
the cost comes.
Yeah,
exactly. The cost comes with it. I mean, the cost itself. Yes, exactly.
So when are we visiting Italy?
Whenever you like. They're always waiting for us there. Mind you, to visit our plants, we have plants internationally, anywhere from the US, Mexico, South America, Slovakia, Africa. Again, they're manufactured worldwide, so we can travel almost anywhere around the world for these Gabions. And going back to the carbon footprint, again, testing has been done not here in Canada, but again, because we're an international company, they're done through our corporate head office. They've done all this, and they've gone through a lot of the methodologies in producing these test results when it comes to the Gabions themselves. And this gives you some indication of the reduction in carbon footprint, the reduction in CO2 gases by using these walls. So again, it goes back to the sustainability aspect of these walls, that a lot of times, as much as cost, sometimes a contractor might look at the cost of it, or the owner might look at the cost. Then overall, if you think about it, sometimes use of Gabions, yeah, there's other aspects of the Gabion that should be taken into consideration when using it. So, Ahmed, that's it. We're at the very end of this. Hopefully your audience enjoyed it.
It was interesting, in fact. I like it. And
thank you so much. Thank you. I enjoyed doing it. I mean, I've been with this company over 20 years, and I find every year is a challenge in one form or another, and it's one thing or another. And yeah, myself and for the audience, Ahmed and I go back for a while. We met at a CGS conference here in in Ontario. I forgot which one it was exactly, and we became friends. And to this day, Ahmed keeps bringing me to his Turkish restaurants for very good places to eat. Which I thank you. Thank you very much, Ahmed, for having me, and thank you for all your hospitality.
Thank you for being with us, and I really appreciate it and accepted my invitation for this. I was always interested in Gabion, wasn't. I think it's worthy to understand them, worthy to use them, and being having this presentation will make it more clear to many audience, and many of my followers or friends, engineers, colleagues. It's nice to show this in a video on YouTube. Sometimes you don't have the time to read, but you can watch something couple of times, and you will understand much more better. Thank you again, Santino. It was great, and hopefully we will cooperate more in the future. Thanks a lot.
No problem. Thank you very much.
Have a nice evening. Bye-bye.
Yeah, take care. Bye-bye.